Welcome, everybody, to this edition of X Live, coming from iXblue's headquarters here in Saint-Germain-en-Laye. My name is David Cunningham, and I'm joined here by Jocelyn Monceau, who's the product line manager and technical lead of the Cetos product lines that we'll talk about today. So the order of today is a little bit complex. We've got a short presentation with Jocelyn, and then we'll be joined by a representative of the French Navy who will join us live on a video link from the south of France. And then we hope then to have some time for your questions after that. So please post any questions you have on the webinar platform, and we'll do our best to answer those at the end of the exchanges with Jocelyn. So we're here today to talk about the Cetos suite of products. And these are designed for enhancing resilient positioning and navigation awareness. So maybe Jocelyn, you can start by giving us a quick overview of what the products do and what they're about.
Yes. Hello, David. Hello, everyone. So the Cetos range of products is about navigation safety. Making navigation safer. And what really matters with this is situational awareness. And by that, I mean knowing where you are and what is around you at all times. This is how you make quick decisions, good decisions, and avoid accidents at sea, So the Cetos range of products addresses those two challenges with two different parts, two different products, one for each of those challenges. The first is the CTOC Positioning algorithm that helps you know where you are. As everybody knows, for the past few decades, we've relied on GNSS to get a position, but this is not reliable anymore because of risks of spoofing and jamming, especially in coastal navigation. So the CTOC Positioning algorithm provides a resilient position, GNSS-free, immune to spoofing or jamming, and it can even detect, those kind of actions, spoofing, jamming, and send you an alert. So that's quite a powerful tool. Mm-hmm. Another challenge is monitoring the situation and having all the information of what is going on around you. So to do this, you have to look at the radar image and the navigation charts and the outside world. This is a lot of information to process, and we have to find a way to bring this information to the crew members in a more efficient way. And we do this with Cetos Evision. This is an augmented reality software that blends all of that information in a panoramic video, and it's very efficient, improves situational awareness a lot.
Okay, that's great. So the Cetos Epositioning, Cetos Evision, these are the two things we're going to talk about today. Let's start initially now with the Cetos Epositioning. Tell us how that works, what information it uses, and give us a quick overview of that.
Yeah, well, it uses all the information available, it uses all the sensors that you can have on your ship and use them to get a position, mm-hmm. a resilient one. So the main examples are the radar, the cameras, and the eco sounder. Mm-hmm. Those sensors, they give you information about the outside world. It lets you know what is around you. And if you have a detailed enough map of the region where you're navigating, then you can try and match this information about the outside world with the map, mm-hmm. and try to refine your position in this area. So this is how Cetos work. And the output of the algorithm is what we call pool of errors. This is what you see on the bottom part of that image, those blue areas. They represent areas of high probability of presence, So the darkest blue area represents a 50% probability of presence, mm-hmm. and the light blue area a 95% probability of presence. And you can see that when we start comparing data from the sensors with the map, the areas start reducing and changing and converging. But we'll talk about that.
Okay, so we can use radar, we can use visual cameras, and we can use potentially bathymetry, and we're relating that to something. So in the case of radar, what are we actually comparing the live radar data with?
Well, a radar image is mainly characterized by the topography of the region you're navigating. Most of the reflection in the image comes from rocks, mountains, and land in general, and you can see a clear coastline on your image. And we happen to have a very global and precise map of this land. This is what we call digital terrain models. It's measured by satellite, and it gives you the elevation of any point on Earth.
So these DTMs are in the public domain. It's nothing proprietary.
Yes, exactly, and they're embedded in the Cetos Positioning product. Of course, if you have private DTMs with a better precision, you can also use them with Cetos and add them to have more performance.
So it's comparing the measurements from the radar, the observation from the radar, with this theoretical model, or this actual model, the digital terrain model of the world.
Yes.
And what other data can be used, and how can that be used?
Well, this was the example for the radar, but it basically works the same with all the sensors. So with cameras, we will use the horizon line, separation between the sky and the land, and we will use the same DTMs, the same terrain models, to compare this horizon line with the map. So in every possible position, we build the horizon line that we should be seeing, and we compare it with the horizon line that is detected on the image.
Yeah. And then with the bathymetry, presumably we're just looking at the bathymetric data from the chart, and we're comparing that.
Yeah, exactly. That's the same thing below the surface.
So very clever, very smart, lots of computing power. What sort of precision can you anticipate from this sort of system?
Well, in optimal conditions, you can get down to a few meters, The more sensors you add, the more precision you get, because they are all complementary in a kind of way. They all work together. So the more you add, the more precision you get. So down to a few meters. Of course, this will depend on the navigation conditions. If you're navigating at night or during a foggy day, obviously the precision from the vision system will not be as good as during daylight with the blue sky. This system is not designed to be the main system to give you a very precise position and navigate always with that. But it gives you sufficient precision just to check that your GNSS is working okay, and be complementary with the INS, for example.
Sure. Okay. Yeah. So we're not looking to replace everything with this technique.
Yeah, no,
we're looking to complement other methods
with
this robust solution. So what happens in the case when GNSS isn't available, or if it becomes corrupted during the navigation?
Well, nothing. I mean, CTOC Positioning does not use the GNSS, and that's its strength. The only thing that it needs is a rough estimate of the position, just to know in what region, what area we're navigating, and then it will refine your position inside that region. And this estimate can be a few nautical miles, so it can easily be input by a user manually, by a crew member. It can also come from an INS, something like this. But I'll show you on a short movie what happens when the GNSS gets spoofed.
Okay. Yeah.
Okay, so this is a video that was recorded in the south of France while we were testing the CTOC Positioning in one of iXblue's ships. So what we're looking at right now is a view of the EGDIS system, and you can see that there's a route plotted in red, and the ship's supposed to be following that route, and it's drifting away, And this is because we enabled some kind of artificial spoofing inside the software. What's happening really is that the ship is following the route, but the GNSS is getting spoofed. So, you get a big red alarm telling you that there's a problem, and you start panicking, and you have no position. And what we're going to do is we're going to enable now the CTOC positioning software and see how it will help us understand the situation better. So we're going to see those pool of errors that I was talking about earlier. There it is. So, the dark areas in the middle are the areas with the higher probability of presence. And you can see that it slowly converges towards a position that is actually on the route. So you start understanding that you're getting spoofed and your ship is actually following the correct path, the correct route. And at a certain point, Cetos, will raise an alarm and tell you that there's a risk of spoofing right now because its position is not coherent with the GNSS. This is the yellow line that you see here. The alarm is sent directly to the EGDIS. And in a few seconds, what we're going to do is we're going to disable the spoofing. So the black circles here representing the GNSS position will go back to the true position of the ship. And we'll see that there it is. It's right inside the dark area, showing that the Cetos positioning algorithm gives you a very precise position.
Okay, so just to get some scale on that, the search area here is a kilometer square. Is that?
Yeah, you have all the information in the right panel on the EGDIS. So yeah, it's about a kilometer wide. The big search area, the big square. So the final 50% probability of presence area is about a few dozens of meters wide. So no, not as precise as a GPS working correctly, but enough to navigate.
Sure. Yeah. Very, very interesting. So you mentioned INS earlier, and so what does the Cetos positioning technique bring that an INS doesn't?
Resilience to spoofing, basically, because it does not really matter what INS you have if the spoofing is smart enough and slow enough, it will bring a wrong position into the INS and the system won't work, or you have to buy very high grade INS that we provide at iXblue, but it's going to be very expensive. So yeah, no, CTOC positioning is resilient to spoofing, and that's a major strength. And it's because it looks at information from the outside world, and this information cannot get spoofed. You cannot spoof a horizon line. You cannot spoof the terrain around you. So it's always going to work.
So one could imagine, it's a complementary system with an INS, perhaps, but perhaps it allows an option to use perhaps a lower performance INS, complemented with this other technique.
Absolutely.
On smaller ships. Yeah. So what does the actual hardware look like? Talking about size of ship that we might install this on. What is?
Well,
we've got to crunch a lot of numbers.
Yeah, it's a simple 2U 19-inch rack mount server crunching the data, and then it connects to the sensors that are already installed on board the ship. So it's quite easy to integrate it. Just small box crunching the data.
Very good. Interesting. Excellent. So moving on now from that little introduction about Cetos positioning, we'll now move on to the second topic, which is the Cetos Evision. Give us a little overview of that, Jocelyn.
Yeah, so Cetos Evision addresses the second challenge about navigation safety, which is be aware of what is around you. And as I was saying, the problem is that information comes from too many different sources. So we try and blend all the information, especially what you get on your charts and what you get when you look at the outside world, the real world. We mix all this together in an augmented reality scene, and it makes it very, very efficient to understand the situation. So
how does that look on when installed on the vessel? What does that look like?
Yeah, so this is the global setups. So you have 3 augmented reality screens. So those screens are in the bridge, and they're connected to cameras on the ship, preferably looking forward, because that's what is of interest. And it's also connected to the EGDIS system to exchange some of the nautical objects, the objects that you have on the charts. So the final view is the real landscape that you extract from the cameras in a panoramic video with all the objects superimposed on it in an augmented reality view, like is drawn here.
Okay, so no goggles, no headsets. What does it actually look like in
Yeah, no
in
goggles, because crew members have to remain free of their movements, and it's very important for them to talk and exchange about the same screens. That it's important that they all look at the same thing. So it's 3 screens in the middle of the ship, and it's. And
I'm going to see my route projected on a real world view.
Yeah, exactly. I'll show you.
Yeah.
We did a quick movie on that too. There we go. So we're back in the south of France.
Okay, nice.
Two parts video here. On the bottom part, you have a recording of the EGDIS screen on which you can see several objects are already plotted. And on the top part of the image, you see the 3 augmented reality screens that display that panoramic video. And so you can see that the route appears directly on top of the sea in the panoramic image, and you can see the port and starboard limits and check very easily that you're on track. You see also those black pins that are buoys and beacons that you get from the charts, and you can see that when you plot an area just in front of you, it appears instantly on the screen. So you know that you're entering that area that you just plotted. That could be a working area or something like this, and you know that you're entering it right now, and the sea just appears red. So that's pretty easy to understand.
Excellent, excellent. So that's a very, very quick introduction to the Cetos Evision concept, and I think if people want to learn more, they need to get in touch, and we can show a lot more information, a lot more data, a lot more examples of how it could of the features and so on that we can show.
Absolutely.
So that's the Cetos Suite in a nutshell. The 2 elements, the Cetos Positioning, bringing a sort of a GNSS independent positioning solution to act as a sort of a second line of defense, perhaps against GNSS jamming or spoofing. Maybe the INS could be thought of the first line of defense. This could be the second line of defense.
Yes.
Really interesting. And then the Cetos Evision being the sort of the situational awareness enhancer for the modern world. And we could imagine, if we look over my shoulder, we've got the DRIX, the iXblue drone.
Yes.
As the world tends towards unmanned solutions, these sorts of techniques, these sorts of ideas will become more and more valuable, let's say, as fewer and fewer people are involved in the real-time operation of maritime assets. So last question, just for you, Jocelyn. I mean, how easy is this all to test? If a customer wants to says, yes, we'd like to have a go, how easy is it to test it?
It's very easy. We actually have a demonstration kit ready to be installed on your ship. It connects to all the sensors that are already installed, so no work has to be done with that. And if you happen to be on a ship that has no cameras, we can also provide small optical block, very easy to install behind the ship's windows, just for the sake of the demonstration, and have it running very, very quickly.
Okay.
So we actually did that with the French Navy for the last few months. They were interested in the solution, and we put this demonstration kit on board one of their ships.
Okay, yeah, which then leads on very nicely to the next part of our presentation here today. And we'll be joined by Commandant Grenet from the French Navy on a live video link and Jocelyn will conduct an interview with the commandant in French, but we will have a live translation into English for the viewers. So over to you, Jocelyn,
thanks,
and welcome
David.
to Commandant Grenet. Bonjour.
Bonjour, commandant.
Good morning, Commander.
Hello, everyone.
Thank you for being with us for this X-Live session and to answer our questions. We're going to talk about the experimentation in a concrete manner and how we put this in place. But before we go into detail, could you please tell us about CEPN, which is the body that you are working with and which has conducted
Certainly.
this experimentation?
The CPN is the Expertise Center of the Naval Programs in Toulon, France, and their mission is to ensure technical and operational expertise for the headquarters of the Navy, to follow up on the program, on development and testing equipment for submarine and surface vessels.
So we were talking about the navigation safety. I assume that this is of very much significance for CEPN and the fact that it was important to know your positioning and to provide information that is easy to understand to the sailors to avoid accidents. What is your view on the topic?
The ergonomics of future ships and on-bridge techniques are changing. The studies of various weapons systems shed light on the requirements to adapt integrated navigation systems to better respond to the needs of the future Navy. And dissemination of information has to be more visible so that so the crews can be able to provide a better safety.
Okay, so we understand the connection with the Cetos Suite, and we are going to talk about the concrete way how the test phases took place over the past few months. But could you please explain how the CEPN come in contact with iXblue and how did you find out about the Cetos solution?
Is working with the Marine National Navy to work on special navigation systems, and we have a technology watch ongoing in the Navy of a military nature. And we had a visit from your company in 2019, so we had some areas of convergence, and we went into some experimental activities with you.
Okay, so that's when we've been able to present the Cetos solution to you. So what did you like about it? Why did you decide to test that Cetos solution?
It was a product that was in development phase, by iXblue, and the CEPN wanted to assess the system so that we could provide some added value to the future Navy.
Okay. So after those discussions between iXblue and CEPN, we've been able to put in place those test phases and that experimentation in order for you to be able to assess the Cetos solution. Could you please describe the experimentation that was put in place, the length of it, and the boat that you've been choosing?
The experiment consisted in testing Cetos over 10 months, and we're entering into the final phase. We deployed a lot of equipment on one of these ships, composed of a camera, a computer, a quadrant system that's independent, and iXblue was in charge of integrating all of the equipment, respecting cybersecurity standards without impacting the existing, equipment on the ship. That was part of the contractual relationship. So the first step of that experimentation, the computer compared in real time images of the relief that was captured by the city and amended to make it possible to continue defining the position of the ship. In the second step, in the summer, radar was added to that, so we added that second sensor. So this is currently running in this configuration. It's independent from the existing system, so that we could criticize and see if it corresponds to our requirements.
you were mentioning the Lear Mine Hunter, which is the ship that has been used. Could you please explain to us why you chose that mine hunting ship?
Experimentation had to respect certain criteria. We worked regularly on the coastline and it can be far from the base. It also has to be remain accessible with back and forth between the training area to facilitate the experimentation.
Okay. As far as the performance and the use is concerned, are concerned, for confidentiality reasons, we're not going to be able to talk about how to manage the loss of GNSS on board French ships. But just to talk about the performances of Cetos Positioning, you've been able to see it in operation on board the ship. What has been your perception? Do you think it was providing sufficient accuracy for navigation purposes?
I'd say that today we consider that it's high performance. The system is robust. It makes it possible for the navigator to determine the position with a certain number of uncertainties that vary depending upon the elements present.
Okay. Regarding the accuracy, the level of accuracy, what can we expect from Cetos Positioning, according to you?
We identified a 50 to 60 meter precision with just the video. Now, in that particular phase of the experiment, if we imagine we integrate new sensors, whether it be as echo sound and radar, the positioning could be reduced considerably and improved. So the positioning, the alternative positioning, is non-negligible if there's any case of jamming or spoofing and you lose your normal navigation.
That's very interesting.
Information.
So Cetos Positioning is limited today to coastal navigation. We understand that it needs horizontal horizon lines. Is it a problem for you, or that multi-sensor algorithm, should it be able to continue to work, to operate offshore?
If the follow-up has to be more rigorous and precise along coastlines, we cannot neglect the coastline navigation. So the interest in evolving this towards use on the high seas is obvious.
Okay. So in order to talk briefly about Cetos Evision and augmented reality that was tested on board that ship, we were explaining that the main interest of Cetos Evision was to provide to sailors relevant information in a blink of the eye, thanks to augmented reality, in order to speed up decision taking and to reduce risks. Do you think that's a relevant approach?
Yes, indeed. I think the ergonomics of it is incredible, and augmented reality and displayed throughout the bridge, all of the players, all of the people involved, and be aware of the optical and other input. Anybody on the bridge during the mission can all the information they need on the elements present in the environment.
Very well. Well, thank you very much, Commander, for those answers and for being with us today. I would like to thank you for the monitoring of this experimentation and for the work that we've been doing together. Thank you. Thank you so much.
See you soon.
You.
Okay.
Okay, well, hopefully that was, yeah, merci, Commandant. Hopefully that worked for everybody, and the translation was helpful.
Yeah.
We've got time for a few questions now from the audience, Jocelyn. So let me start with a few which are coming in now. So in terms of sensors, do I need specific sensors with radar and camera, or?
Well, no, you can interface with all the sensors that are already installed on board the ship. So you do not need to have a dedicated radar or echo sounder for Cetos. You just interface Cetos with the existing sensors that you have on your ship.
And so another one here about moving on from there. Another one here about sensors and looking at the cameras in particular. So both Epositioning and Cetos Evision are using cameras. Can they use the same cameras?
Yes, you can absolutely use the same set of cameras for both of the products.
And so here, so here's another one. How many sensors can be used as inputs for Epositioning?
Yeah, that's a good question. We gave example with cameras, radar, and echo sounder, but you can use as many sensors as you want, basically. So if you have, I don't know, 2 radars, that's often the case, or several echo sounders, you can absolutely connect all of them. And as I was saying earlier, the more sensors you use, well, the better precision you will get on the final position information.
So we've got one about echo sounders. So could Cetos Epositioning use input from a multi-beam echo sounder?
Yes, it could absolutely. It's never been done, but it could totally be like that. It's very easy to do, and obviously we will have a much better performance with a multi-beam echo sounder, because instead of having a single measurement, a single depth, we will have a scan of the bottom of the sea.
Okay.
So yeah, this would improve performance a lot.
Sure. Yeah. So it would be an advantage. What about the ECDIS? There's a question here saying, can it be used with any ECDIS, or would it need to be the iXblue ECDIS?
Yes. Well, for the Epositioning part, we were seeing the pool of errors displayed on the ECDIS. This was iXblue's ECDIS, and you have to use iXblue's ECDIS if you want this output. But if you don't have it, you can still use Cetos Positioning, because it sends all of this information, to the network of the ship. And you have the position information in standard protocols, so that's okay. As for the Evision part, the augmented reality scene is synchronized with the ECDIS in order to get the objects. So if you want the custom user objects, the areas, the custom marks, you have to use iXblue's ECDIS. But all the nautical information, the buoys, the beacons, these kind of things are available with another ECDIS. No problem with that.
So standard formats.
Yeah.
What else have we got? So talking about cameras and the field of view. So it uses, So can you get a 360-degree view? And how does the system work at night?
Yeah, those are very common limitations of cameras. That's a very common question about the system. Having a 360 degrees cameras is possible. It just depends on what hardware is available on the ship. If the ship has a 360 degrees camera, then obviously Cetos can use it. As for the night vision, well, I'd say it's the same. If the ship has available infrared cameras to see at night, obviously we will be able to use it. The thing is, for Cetos Evision, even if you don't have the image at night because, well, it's dark, you're still gonna see all the virtual objects. You're still gonna see the route, the beacons, the areas on a black image. But it turns out that it remains very useful,
Yeah. Okay. Yeah. So in the case of if you've got the right sorts of cameras, we can adapt the system to accommodate those.
Yes.
whether it's a 360-degree camera or, as you say, infrared cameras
Absolutely.
for nighttime vision. So we've got a question asking what the orange thing is behind me. Well, it's a DRIX. It's a model of the DRIX. We were a little bit at a loss what to put on the set here, so we decided to put the DRIX. It's iXblue's drone, surface drone. It's an 8-meter long boat in reality, used for hydrographic survey and geophysical survey and various monitoring exercises. And I think, as we mentioned earlier, we could imagine these types of navigation solutions being deployed on unmanned platforms or uncrewed platforms, remote controlled platforms, with the idea that these sorts of situational awareness and secure navigation solutions become more and more relevant as fewer and fewer people are involved in the real-time operation on site. So this is why iXblue is developing these sorts of techniques and these sorts of ideas to complement the other navigation sensor and system product lines that iXblue has.
Yeah.
I think we've got we've got time for a couple more questions. What precision is this about cameras? I can't really tell.
Yeah, I don't understand that one.
Oh yeah, what's the precision of the on the displays? Or what we have?
I'm not sure I understand the question.
I'm not sure I'm getting it either. No. Okay. So I think maybe we've run out of time for questions. I think we're not getting any more. Yeah. So let's Oh no! Here we got one more. We've got one more. So I mean, you touched on this earlier, but maybe it's useful to say it again in case somebody's joined here. So can you explain better how the Cetos Positioning uses cameras for positioning?
Yeah. So that's what I was saying earlier. With the cameras, we use horizon lines. We detect the horizon on the image, and we compare it with the digital terrain models.
Okay.
So what happens is we have actually a horizon detector on the image based on an artificial intelligence algorithm to tell us where the horizon line is on the image. Then we use the terrain models to simulate at a given position, looking in a specific direction, what horizon should appear on the image. Mm-hmm. And then when we compare the two lines, we're able to say if it matches well or not, and it gives us information about if this is a probable position or not.
Okay, and so rather than just taking one view, one measurement, we're doing that thousands and thousands and thousands of times continuously.
Yeah. It's done
which
constantly.
Allows you to bring the solution to.
That's why you see the pool of error converging towards a specific position.
Okay. Well, hopefully that helps. So here we go. No, so this is one about the DTM. Okay.
Yeah.
Now I understand. So what precision is needed in the DTM in order for it to be useful for the e-positioning application? So maybe start with explaining the resolution of the DTM that's in the public domain and available to everybody. And
yes, exactly. So the more precision you have on your DTM, the more precision you get on the final results, obviously, because you have a better knowledge of the map you're comparing data to. So the precision that we use with the common database that we can use and is available worldwide is about 1 arcsecond. So when you're navigating, let's say at a 45 degrees latitude, it's about 1 point every 40 meters or something like this. But as I was saying earlier, sometimes people have private DTMs available of a specific region where they're operating, and we can use that as well, and it would obviously increase performance.
Sure. Okay, I understand. Yeah. So if a navy, for example, has a data set with a much higher resolution, then that can certainly be
Absolutely.
be
used as the basis for the analysis in this modeling.
Yes, and this is especially true for bathymetric charts. Private ones are often much more precise than public ones, and it's often the data that people navigating the waters have.
Okay. We've got one more question. This is one about the Evision solution. So, and it's somebody's concerned about multiple bright screens becoming a problem at night. How do you manage that issue?
Yeah, that's often a problem on board ships when you have too many screens. There's too much brightness, and it gets very uncomfortable for people during navigation at night, and it can even be dangerous, but all the screens that we use for the Cetos Evision product are marinized screen, fully dimmable, with a centralized control, so you can just turn one small button, and the whole setup is gonna be dimmed, and it's not gonna bother you when you navigate at night.
Yeah. So it's addressed with a conventional, dimming arrangement. Yeah. Okay, I think that is now the end of the questions. So thank you very much, Jocelyn, for answering those questions and giving those explanations of the Cetos Suite. And thanks to Commandant from the south of France for joining us and helping. I think hopefully you've learned a little bit about what we're offering here, what we're able to do. If you have any questions, don't hesitate to get in contact with iXblue. We'll be very happy to answer any queries, and indeed organize a demonstration or a trial of this system on your ship, if that's of interest. I know Jocelyn's dying to get out and about and install the system on some more vessels.
Yes, that's right.
So thanks very much, Jocelyn, and goodbye to everybody.
Goodbye.